Welcome to YouTube channel scientific underscore math and this is the fourth lecture on eigenvalues and eigenvector. The link of previous lecture is available in video description. You can watch. Okay, so in third lecture we solved the example of order matrix of order 3 cross 3 and in this lecture again we solve the matrix order 3 cross 3. But here in this lecture we have the second case when the eigenvalues lambda can be equal to 0, but again I will say the eigenvector cannot be equal to 0 because in lecture 2 we have studied in detail the vectors cannot be equal to 0 because this makes no sense. Okay, so let's start today lecture. Okay, so in this lecture we studied the eigenvalues can be equal to 0, but eigenvector cannot be equal to 0. I will say it again. Okay, so in lecture number 2 we have already studied the eigenvector cannot be equal to 0 because this make no sense. Okay, so for finding the eigenvalues and the eigenvector is the procedure is first we find the eigenvalues of the matrix A by solving the equation, that is the characteristic equation. Okay, so second, after finding the eigenvalues we will find the eigenvector corresponding to each eigenvalue. So second step is for each lambda find the eigenvector that is not equal to 0x by finding the basic solution to this characteristics equation. Okay, so after finding the eigenvalues and eigenvector, then we verify whether our computed characteristic eigenvector are not by this equation. The multiplication of the matrix A with the eigenvector x, which is equal to some scalar into the original vector x. Okay, for each lambda and the associated eigenvector. Okay, so we have an example when the eigenvalue is 0 or 0 eigenvalue. We have 3 cross 3 matrix, that is the square matrix. Okay, so we have to find out the eigenvalues and the eigenvector. Solution. First step is we find the eigenvalues of matrix A by solving the this characteristics equation. Okay, here we have this is the lambda, this is the identity matrix of order 3 plus 3 as the matrix A minus the given matrix A. So we get this one. Okay, to solve this matrix we have a shortcut trick, that is the this equation. This is the characteristics equation when we solve a matrix of order 3 cross 3 general matrix like A11 with entry A22 A33 A4 A21. Okay, A22 and A23, similarly A31 A32 and 32. When we solve this equation we will get this equation, this matrix. We will get this characteristics equation. Okay, I have already proved this equation for 2 cross 2 matrix in the previous lecture. You can watch and you can prove similarly for the 3 cross 3 matrix. Okay, so lambda trace of A, what is trace of A? The sum of elements along the diagonal and the minor along the diagonal, and the determinant of the matrix here will be also lambda. Okay, so here we have the trace of this matrix. The determinant of matrix is equal to 0. Okay, so now we will calculate the minor of the matrix along the diagonal. This is the first minor, first row and first column. First row we leave the first row and first column, and the then the remaining entries. These are, and after solving this one we get. Similarly for the M22, okay, leaving the second row and second column, this is equal to 0, and again for similarly for M33, leave the third row and the third column. Okay, so after summing the M1 M2 to M33 we get this one, and this is the sum of minors along the diagonal. So substitute all these into equation, this one, and we get this equation. Okay, so simplify this equation, and here we get the solving the equation 1, this one. Okay, we find that the eigenvalues are lambda 1 which is equal to 0, lambda 2 which is equal to 2, and lambda 3 which is equal to 4. So here we can see that a 0 eigenvalue. Okay, so now we find the eigenvectors corresponding to each eigenvalues. So now that we have found the eigenvalues of the matrix A, we can compute the eigenvectors. By definition, we know that the eigenvector is equal to this one for 3 cross 1. Okay, is an eigenvector of A corresponding to an eigenvalue lambda if and only if X is a non-trivial solution of this equation. Non-trivial means non-zero. Non-zero. Okay, so next we have, first we find the eigenvector for lambda 1 is equal to 0. Okay, so we substitute lambda into this equation, and this is the identity matrix of order 3 cross 3 as the matrix A. This is the eigenvector, and after solving this one, okay, we get this form, and we write the augmented form for this system, and then we row reduced into this form. Okay, so row echelon form for this augmented matrix. After some simplification, here we can see that we have two pivot columns, this one and this one, because the diagonal entries are not 0, and third one is the not pivot column because the diagonal entry is 0. Okay, so we again write this into this form. Ax is equal to b. Column 1 and 2 is a pivot column. These columns correspond to variable x1 and x2, making these the basic variable, but the third column is not pivot column, which means x3 is free variable. Okay, so what we do when there is free variable appear, we suppose them equal to some constant k, and after multiplication of this one with this one and this one with this, we get this one x1 which is equal to 1k, and x2 is equal to 0. Okay, we write them in the vector form, and then we take the k common where k belongs to real number, and here we can see that therefore the eigenvector are of the form where k is equal to not 0, and the eigenvector is given by this one. Okay, so this is the eigenvector corresponding to the value lambda that is equal to 0. Okay, now we verify them. Is the uh, calculated vector correct or not? Okay, we can verify the eigenvector is correct by checking that the equation ax which is equal to lambda is 0 as. Okay, this is the matrix A, this one is the eigenvector, and after multiplying these with each other, we get the 0 vector. This is clearly 0 into x, so the equation holds. Hence, the a into x1 which is equal to 0, that is the lambda into the eigenvector x, and so 0 is an eigenvalue of the matrix A. Okay, so computing the other basic eigenvector is left on an exercise for lambda 2 and lambda 3. You can calculate the eigenvector. This is exercise. Okay, so thank you so much for watching my video. Please subscribe my channel scientific underscore math.